Let us now study the next topic, that is production of induced EMF by changing the relative orientation of the coil with the magnetic field. Okay. See now what happens is, one way we learned that we can change the orientation of the coil, that is angle theta we can change to produce a magnetic field. Okay. So there are two ways. One, you can either rotate the magnetic field, or otherwise you can also rotate the coil. Okay. Anyway, the angle will change. Okay. So magnetic field can be changed, or the coil can be turned like this way. So now we have a coil here. Okay, so this is a coil here. Okay, draw here coil, and this is a magnetic field here B. Okay, it goes from left to right. Magnetic field goes from left to right here. Now this is a coil. It has n number of turns. Okay. Now let us see what is the initial time. That is at time is 0. Okay. So at time is equal to 0 seconds. Okay. So at 0 seconds, what happens? Okay. So in this case, the plane of the coil is perpendicular to magnetic field. Okay. So this is the plane of the coil. It is perpendicular to the magnetic field. The coil and the magnetic field are perpendicular to each other. Okay. So the plane of the coil is perpendicular to the magnetic field. Okay. To the magnetic field. So in this case, let's see what happens now. Okay. So we have maximum flux linkage. Okay. So we compare. You go to the topic about flux linkage. Okay. In magnetism lesson, and you can see, or in this chapter you will see that how the flux linkage is maximum. Okay, so in this case the maximum flux linkage happens here. Okay, let us study what is the maximum flux linkage. Flux linkage formula is phi. Okay, and here n phi also can write here. Okay, not n phi, here just simple phi only. Okay, maximum flux linkage is phi. Okay, sorry, so phi b, that's a flux linkage. Okay, that will be equal to NBA. Okay, actually flux formula is phi is equal to BA only. Okay, this is the actual formula. Okay, phi B, but we have n number of turns, so we multiply by n. Okay, now after some time, okay, after some time what happens is we rotate the coil here in the anti-clockwise direction. So the coil rotates like this way with a speed here omega. Okay, so after say t seconds, okay, the coil goes to a new position. Okay, the coil turns by an angle theta. Okay, the coil rotates anti-clockwise by an angle theta. Angle theta here. Okay, so this angle theta, if you see, the theta is equal to omega t. Okay, theta is equal to omega t here. That's a formula for this one. Angle theta. Okay, so here this means angular velocity. Okay, so we'll see the picture how it happens. So you can see this coil here, it rotates anti-clockwise direction, so it goes like this way. Okay, it happens like this here. Okay, now I'll draw the midpoint of this coil here. Okay, this coil is rotated by this way, and then we'll just see this is a magnetic field. Okay, so let's take this angle as theta. Okay, it's drawn a little bit larger in size here, the coil. Okay. So it has made an angle here, that angle is theta. Okay. Now we see what is the thing here. Okay. So this will be the vector here, the area normal here. Okay. So the area normal, sorry, this is the area normal, it makes an angle theta with this magnetic field. Okay. So what will be this portion here? Okay. So what will be this portion, we'll see now. Okay. So in this case, if we see this part, okay, the magnetic field, we can just divide into two parts, that is horizontal and vertical component. So this is angle theta now. Near to that, we'll get the horizontal component, that is B cos omega t. Okay, theta is omega t. Okay, and this side will get this vertical component, that is B sin omega t. Okay, so magnetic field is split up in two parts here. Okay, so B cos omega t and B sin omega t. Okay, now in this case, we'll see that B cos omega t only hits the coil here. Okay, B sin omega t does not produce any EMF. Okay, so we'll just leave this B sin omega t. We'll take only B cos omega t. Okay, so in this case, let's see what will be the flux linkage here. So n phi b is equal to, we'll have here n b a, and then we also have this cos omega t. Okay, So actually why? Because theta, actually you have cos theta and the substitute theta is omega t, so it can be a cos omega t. Okay, so now we will use the Faraday's law. Okay, according to Faraday's law, we have here the EMF is equal to minus d by dt of the flux linkage, that is n phi b. Okay. So substitute the value of n phi b in this equation. So what we have is minus of d by dt of this n phi b is nba cos omega t. Okay, so you have to differentiate this. Okay, let's differentiate this and see. Let me erase this portion here. So let us do the differentiation here. I erase this and written on top. Okay, so we get here minus d by dt of this one quantity we have now. So what you do is take the constants outside, that is nba, that is number of turns, b is the magnetic field, a is the area of the coil. You take them out. So nba comes out. Okay, they are constant. So d by dt of cos omega t. Okay, so let us see how to differentiate this now. So we get here minus nba. Okay, differentiation of cos theta is minus sin theta. Okay, so minus sin omega t. Okay, that we have now. Okay, and it's also differentiate this inside also now, omega t. So we have d by dt of omega t. Okay, again you see omega is a constant. Okay, the angular speed or angular velocity. So you take it out. Okay, so what you have is minus nba into minus sin omega t. Okay, into omega comes out and dt by dt. Okay, so t will be remaining now. So now you see dt by dt is 1. Okay, and then we see now minus into minus will become as plus. Okay, so plus nba, and then omega is also there. We bring the omega front, sin omega t. Okay, so this will be the EMF we get. Okay, but now let's see a condition here. Okay, so when the coil is rotated through 90 degrees. Okay, if you rotate this coil, so first it was like this way now. Now you rotate the coil 90 degrees, that means it will be like this way. Okay, so when the coil is rotated 90 degrees. Okay, so when the coil is rotated through 90 degrees, it's rotated through 90 degrees, what happens we'll see now. Okay, from its initial position, how the picture will look. See, this is the magnetic field. Okay, and the coil now has rotated by 90 degrees. Okay, initially it was like this way, now it's rotated 90 degrees and like this way it will become. So the coil will be like this way. Okay, see here. So this will be the shape, this will be the position of the coil. Okay, so magnetic field will hit this, and left side, if you see, it's actually a rectangular coil only we have now. Okay, left side and right side. So that time we'll have a maximum EMF produced here. Okay, so in this case we'll have the maximum EMF. Okay, so we'll have the maximum value of induced EMF will be produced here. That we'll see. So I'll take this equation here. Okay, let me note this equation. So equation 1. Okay, so in this equation what happens is the angle theta becomes 90 degrees. So omega t will become 90 degrees. Okay, so omega t is, or theta is equal to 90 degrees. Okay, so substitute this one 90 degrees. So what we have is the maximum EMF is equal to nba, and then you have here sin 90. Sin 90 value is 1. Okay, so sin 90 value becomes 1 here. So we get here the maximum EMF is equal to nba. So maximum EMF. Okay, so this one we will name it as equation number 2. Okay, so now we got equation 1 and equation 2. Okay, so what we do is we're going to substitute equation 2 in equation 1. Okay, let me write equation 1 and 2 with this side, then I erase this side now. And one more thing I have forgotten, that is omega I have forgotten. Okay, you should write omega also here. Okay, omega was there now. Okay, so equation 2. So instead of this nba omega, we're going to write as em or epsilon m. So let us substitute equation 2 in 1 and see. Okay, so equation 1 we have now, that is E is equal to nba omega sin omega t. Instead of nba omega, this term we are going to write as em or epsilon m. Okay, so it here epsilon m. Okay, and then we get here sine omega t. Okay, so this is the equation that we get for the EMF produced when the coil rotates in the magnetic field. Okay, so this one we named as equation number say 3. Okay, and this EMF is a no. Okay, this EMF is also called as the sinusoidal EMF. Okay, the EMF produced, it has a name, sinusoidal EMF. Okay, or else you can also call it as alternating EMF. Okay, that means EMF which will change. Alternating EMF, the EMF which is produced alternatingly. Okay, now let us see the position of coil in a different way with pictures, and we'll see the graph also. Okay, let's see how it is done. Now I have drawn different diagrams for the different positions of the coil when it rotates. Okay, let us see how it rotates then. Okay, first the coil will be like this way. Okay, it's actually three-dimensional. Okay, it's very difficult to draw two-dimensional, three-dimensional on the board. So this, let this book be the coil here. Okay, this is the coil here. First the coil is perpendicular like this way. Okay, that is the angle is 0 degrees. Then the second picture, what happens, it rotates like this way, rotates by 9 degrees. Okay, then third picture, what happens is it rotates like this. Okay, and the fourth picture, it turns like this. Okay, then next one, it turns like this way. Okay, so this is the way it rotates, like this way. Okay, in this direction, that's in the clockwise direction. Okay, see here. Now what we must do, we must see what is the value of the EMF produced. Okay, so EMF formula, that is epsilon, that is equal to EM sine theta. Okay, in this case sine 0. So what's the value of sine 0? Sine 0 value is 0. So first one, we have no EMF. So that means if the coil, okay, excuse me, if the coil is kept like this way, okay, no EMF is produced. Okay, next we'll see what happens in this case here. I'll draw lines here. So in this case, the EMF is equal to EM sine pi by 2. Sine pi by 2 means sine 90. Sine 90 value is 1. So we get here maximum value of EMF, that is EM. Okay. Next, third one. Okay. And before that, I will see the angles here. So this is the angle that is 0. Pi by 2 means 90 degrees. Pi means 180. Okay. This will be 2 pi by 2. 2 pi by 2. 2 and 2 will cancel. That is, we get here pi. Then we get 3 pi by 2. And then 4 pi by 2. 4 pi by 2 means what? 4 and 2 will cancel. So we get here 2 pi. Okay. That's how it comes. So that's the angles we got now. Next, third picture will go here. The third picture we get here, E is equal to EM sine, okay, that is pi. Okay, so what is sine pi means? Sine 180. Okay, sine 180 is what it is, value is 0 only. Okay, so we get here third one 0. Okay, next one, fourth one. So E is equal to EM sine 3 pi by 2. Okay, this will be say 270. Okay. In this case, you see this angle will be minus 1. So we get here minus EM. Okay. Then last one, E is equal to EM sine 2 pi. Okay. Sine 360. Sine 360 is like 0 only. So we get here 0. Okay. So this is the way we get these values here. Now we'll see, these numbers are a little difficult to understand. So we'll see a graphical format. That's more easy. So let me draw a graph here between EMF and this angles here. Okay, so this side we have here the EMF, and on this axis we will have this angle, that is omega t. Theta is equal to omega t. Okay, so first one, you see this is 0 degrees. Okay, and this will be, we'll draw vertically. Okay, lines this way so that we can mark the angles here. So this is 0 degrees. Okay, and this will be pi by 2. Okay, this will be 2 pi. Okay, this side, this one, that will be 3 pi by 2, and this will be 4 pi by 2, that is 2 pi. Okay, so that's the angles here. So now let us see what will be the EMF produced. So EMF will vary from a maximum value, that is plus EM, okay, to a minimum value, that is minus EM. Okay, so positive quantity and negative quantity, it will vary. Okay, so let us see what will be that. So first one that we plotted was 0. Okay, second one we had EM, that's the maximum value. Okay, the third one we got 0. Then fourth one we got minus EM, that will be here. Okay, fifth one we got 0. So if you join the points, see, okay, we get actually a curve like this way, a wave like this way. Okay, so this is a sinusoidal curve. Okay, sine wave. Okay, so we can say the EMF varies sinusoidally, and the current also will vary sinusoidally. We can say that is a alternating current also. Okay. So current is also alternating current. So we got the equation for EMF now. That is E is equal to EM sin omega t. Same way for current you will get here, that is I, okay, is equal to Im sin omega t. Okay, here Im is the maximum value of the current here. Okay, so these two equations you must remember. Thank you for watching.